Here we're going to set up a Flybar mechanical mix model. If you have a Flybarless mechanical mix model, then it'd also be good to watch the Flybarless setup part of this section. The first thing you want to do is, out of the box, get all your servos mounted, and with all the servo arms off, you want to go ahead and just set everything in neutral. After that, you're actually done with the radio. It's best if you can to have some multiple servo arms. The splines of these servo arms, I think that companies use several molds, and so every one of these servo arms almost seems different. So what I tend to do is, with the radio all centered out, 0 sub trims, neutral collective. Obviously, if you already have your ESC and motor plugged in, you want to unplug your motor so your helicopter doesn't spool. But go ahead and get everything neutral, and then just with the servo arms, get everything 90 degrees. So you'll see here, this elevator servo arm and the rotor servo arm are both 90 degrees. Then we move down through the bell cranks, 90 degrees, and then back here's 90 degrees. And then this current model actually doesn't have adjustable links, but if you have adjustable links, with this all at 90 degrees, these two rods should be the same length, and that will give you a level swash plate. On the ailerons, same thing, 90 degrees. Here you're looking for just 90 degree bell cranks, so on this side of the helicopter, 90, 90. And then same thing, if these are the same and these are the same, you should have a level swash plate. It's still good to check though, because sometimes there could be, if say a hole is a little bit drilled differently on the swash plate, you could, so it's good to check. Swash levelers come in handy for that. Mike Trueblood sells swash levelers. There's all sorts of different companies that have good swash levelers. It is important to buy the specific swash leveler for your heli, because there's different ODs and IDs of swash plates, so some of them are made to fit around, fit under, etc. Main key point now is we'll go and flip the heli around. Tail rotor is a little bit more critical. You want the servo arm 90 degrees, and then when we move back to the tail rotor, most of the helicopters these days have it so that if this bell crank here is 90 degrees, that you'll have the proper amount of tail pitch. If not, what you want to do is center it so that full right and left on the tail shaft, that the tail slider is centered on the shaft. Not equal pitch. You'll actually have more pitch to counteract torque, so you'd have more essentially right rudder than left rudder, but just make sure that that pitch slider is centered in the shaft so that your servo numbers in the gyro will be equal. And just to kind of touch on a little bit of gyro setup as well. In a Flybar model, you only have to set up a tail gyro. So just make sure that your limits, on most gyros, make sure that your limits are close in number, and that you're reaching full travel to full travel on both sides, left and right. And besides that, the best I can tell you is just refer to your gyro menu. Some of the things that are constant with all the gyros, if you're getting a high-speed flight oscillation, then your gyro gain is just too fast. So if you're flying in forward flight and your tail's going just turn your tail gyro gain down. If you're sitting in a hover and it's oscillating fast, it's too high gyro gain as well, quite a bit too high gyro gain. If it's sitting there hunting like this, kind of just slowly going back and forth, and when you let go of the stick, if say you make a rudder input, it kind of wags and kicks back. In most gyros, that means that the gyro gain is too low. So that's a good starting point to get your gyro set up. For the fine tweaking, like I said, just refer to your gyro manual. We're also going to touch on governors real quick. This particular model uses a magnet in the fan. So here we have our gyro sensor. It's good to make sure that this sensor is very stiff and rigid, because if this can wiggle or move with motor vibrations, then that's not good. You won't get an accurate reading from the magnet to the sensor, and your governor won't work very well. On the electrics, you can either use the internal governor. Some of the different models, or some of the different Flybarless systems now have governors built into them as well for electrics, so you can actually run all of it. On this current model, we're using just a tail gyro only, since it's Flybar, so we're using the 701 governor. The biggest thing with that is to follow the governor's instructions once again. Make sure that your high and your lows are set, and also make sure that your throttle barrel is moving linear. That note, we'll move over to the throttle. What you want with that is same basic thing, but the angles might be a little bit different. You want 90 degrees, 90 degrees, but obviously the rod is actually everything shifted like this. But you'll notice the angle from the throttle barrel to here is still 90. When we reach full travel, we want each side to be equal. So in your radio, the best thing to do is actually unplug it from the governor and just set it up so that your neutral is neutral on the barrel, and then go full throttle and full idle, and then make sure that those top and bottom numbers are really equal. I mean, if you're off 10%, that's not that big a deal, but it's best to do that. If your throttle barrel isn't moving linearly, you're going to notice things like if you're using throttle curves, it's going to be very difficult to set those. If you're using a governor, the governor will tend to hunt and do other things like that. Here we're going to go ahead and move on to the collective servo on a mechanical mix model. Same as everything else. First, set the servo 90 degrees. Make sure that your collective tray or whatever's operating your collective is neutral. And then as you kind of go up, this will automatically be set because all these other rods from your collective tray. This is what makes mechanical mix so nice, is it's basically interaction free. But as you go up, you want, as you can see here, the mixer arms are level. Then we go up to the top mixer arms, and these are level. And then you level your rotor blades to 0 degrees. You want everything centered around 0 degrees. If, say, you want to hover at mid-stick, then it's best to change that in your pitch curve, not in your mechanical setup, so that way when you're starting to want to do aerobatics or 3D, you just shift your pitch curve then instead of having some odd top and bottom number. Overall pitch range, a lot of that's personal preference. I would start low and then increase, so that way you're not bogging initially, specifically if it's a new nitro motor or new electric batteries. Some things to touch on while using a pitch gauge, it's best to always find something neutral on the heli. I always tend to use the upper bearing block. So when the pitch gauge is on, use the upper bearing block because that's a flat part to reference your blade pitch off of. On a flybar model, it's best to use a flybar lock or something, or just stick something in there and then do that. Now, one common misconception is that the paddles should be also level to the bearing block. The best thing on a flybar model is not to align your paddles to the flybar cage, not to align your paddles to the washout, but actually align your paddles to the swash plate. That's the best thing. Everything should be based off the swash plate. So that covers mechanical mix setup. For CCPM, we'll touch on that in the next video, and then also we'll touch on flybarless.